All right, so what it's asking, it wants us to define the variables. All right, all you have to do is define the variables and write an equation. You don't have to solve it. So Abigail works as a salesperson at electronics store and sells phones and phone accessories. She earns $14. This is different than the one I've seen before, so this might be a little tricky. $14 commission for every phone she sells, and $3.50 commission for every accessory she sells. Okay. On a given day, she made a total of $129.50 and sold 7 more accessories than phones. Right? Systems equation. Okay. So first thing you gotta do is define your variable. So there's the number of phones she sells and the number of accessories she sells. Right? So phones, and you can. The thing is, part of the tricky thing is you could choose whatever letter you want. So I'm gonna choose P for phones. Am I in caps? I hope not. Whatever. P, the number of phones sold, and I'm gonna choose A for the number of accessories sold. Okay, great. So my systems of equations, the first one is the hardest one. So it's basically amounting to like 14 times the number of phones plus 350 times the number of accessories equals 129.50. So that's your equation. So 14p plus 350, 3.50 a equals 129.50. 129.50. All right, that's one equation. The second equation is this part right here. She sold 7 more accessories than phones. All right, so if she sold 3 phones, then she sold 10 accessories. So A equals the phones plus 7. All right, let's see. If it's wrong, I'll take it off and we'll just focus on the problems. There we go. All right, so doesn't matter. I thought one time when I got it wrong, I thought it was because it was capitals. It doesn't matter that it's capitals. They didn't even let you theoretically choose any letters, but it's easiest if you choose the ones that match the, A for accessories and P for phones. And again on this, by the way, I think I only put 2. Yeah, there's only 2 of these on here. The idea here, I don't want to make you just do unnecessary work. I just want you, it's helpful to force you to define your variables clearly. All right, the second one is the one that's these, and again, I'll give you a choice. I'll let you vote after you maybe, at some point, whether we want the first kind on the test or not. This one is going to be on. A publisher needs to send many books to a local retailer and will send the books in a combination of small and large boxes. Each small box can hold 20 books and each large box can hold 35. Okay, so this we're actually solving, right? So I need to annotate here. So again, hopefully what we did in the last one helps. So the small box, I'm going to call S for small box and L for large box. So 20 times the number of small boxes plus 35 times the number of large boxes is going to be altogether 225. That's one equation. The second equation is this: twice as many small boxes as large boxes. Now, it's tricky the way this is written a lot of times, that you got to realize if she sent 10 large boxes, that means she sent 20 small boxes. So small equals twice large. Now, this is a place where it's kind of good to see like what we're getting into today, which is choosing the right method. Now, there's not a wrong method. You definitely don't want a graph because you don't have a graph here. You could use the elimination that we were learning, but like then I got to line them up. It's going to be 0 on this side, then I have to multiply one of them by like 20. Or this is really perfectly set up for substitution. This is S. This is equal to S. So I'm going to put it right in there. I'm going to go 20 times, I'll do it, 2L I'm just rewriting this whole equation right here. Plus 35L equals 225. So 40L plus 35L equals 225. We'll bring this over here. So 75L equals 225. I just pick a different seat. So L is going to equal 5. That's the large boxes. She put double as many small boxes, so that's 10. I don't know if you want to see their explanation. I guess I'll just type it in. If I can. 10.5. What? What'd they ask? All right, so I gotta do another. They wrote the right equation. Oh. See, this is what I get for doing the math in my head. 225 divided by 75, right here, is 3. But I'll do another one just for whatever's sake, so I can show you one fully correct. And there's different kinds anyway. So, here we go. Anna's working 2 summer jobs. She makes $9 an hour, washing cars, and $12 landscaping. So we're gonna define off the bat. So L equals landscaping hours, and W equals car washing hours. She worked a total of 7 hours. So your first equation, the easy equation, is just going to be W plus L equals 7. However, she might work 3 hours washing cars, 4 hours landscaping, and the total she earned was 75. So this is the harder equation. So this is where you're kind of factoring in the fact that washing cars gave her $9 an hour. Landscaping gave her $12 an hour, and the total she earned is 78. Now, this is one I would say might as well use, what's it called? Let's use the elimination method. I'm going to multiply this by -9. So we get -9W minus 9L equals -63. And we can just add these up. This is eliminated. We get 3L equals 15. So L equals 5. And if they add to 7, so W is going to equal 2. She worked 2 hours running cars and 5 hours landscaping. And let's just check this. She worked 2 hours working cars. That's $18. 5 hours landscaping. That's $60. That adds to 78. So 2 and 5. You know, we're not on a page right now. You're just watching these. Okay. All right. So, and I think, by the way, well, let me stop there. Hang on 1 second. 8:30.